Hi guys, my name is Anton Erling. So I'm here to discuss about thermodynamics ideal gas processes. Problem number 8. Next slide. So the problem number 8. 1 pound of an ideal gas undergoes an isentropic process from 95.3 psig pounds per square inch gauge and a volume of 0.6 cubic feet to a final volume of 3.6 cubic feet if the constant pressure Cp is equals to 0.124 BTU British thermal unit per pounds degree Rankine and the constant volume 0.093 BTU British thermal unit per pounds degree Rankine. What are the A. Final temperature, B. Final pressure, C. Change of enthalpy, D. Work. Slide. And first, what is based on the problem states that isentropic process. So first, what is isentropic process? An isentropic process is a thermodynamic processes wherein there is no heat being produced during the change in state. This process is sometimes known as a reversible adiabatic process, adiabatic in the sense that it does no heat. So here are the given values in the problem. Initial pressure is equals to 95.3 pounds per square inch gauge, and the initial volume 0.6 cubic feet. The final volume 3.6 cubic feet, and the Cp constant pressure is equals to 0.124 BTU British thermal unit per pounds degree Rankine. The Cv constant volume is equals to 0.093 British thermal unit per pounds degree Rankine. And here we are asked to find the final temperature, final pressure, change of enthalpy, and work done flow. So first, we have to solve for the gas constant or determine the R or the gas constant. So we have here the equation. Constant pressure is equals to gas constant plus constant volume. So let's transpose because we are asked to get the gas constant. So gas constant is equals to constant pressure minus the constant volume. So let's now substitute the given values. So the gas constant is equals to 0.124 British thermal unit per pounds degree Rankine minus 0.093 British thermal unit per degree Rankine times the conversion. In 1 BTU, in every 1 BTU or British thermal unit, there is 778 feet pound force. So the cancellation of units here, we can cancel the BTU. So the gas constant is equals to 24.118 feet pound force per pounds degree Rankine. Next slide. So we can also solving for the initial temperature using the gas constant formula. Initial pressure times initial volume is equals to mass times gas constant times temperature. So we have to solve for the initial temperature. So initial temperature is equals to initial pressure times initial volume over mass times gas constant. So substitute the given values. So the 95.3 pounds per square inch gauge plus 14.7, because 14.7 we have to convert pounds per square inch gauge to PSIA, the pounds per square inch absolute. We just add 14.7, so times 0.6 cubic feet. So in every square feet there is 144 square inch over the mass, 1 pound mass times 24.118 feet per feet pounds per pound mass divided by. So here the cancellation of units. So 110 psia, we can cancel it. The cubic feet cancel square the square feet, the square inch, the pound mass, the feet, the pounds, pound mass. So we have here the left unit, degree Fahrenheit, so the initial temperature would be 394.06 degree Fahrenheit. Next slide. Solving for adiabatic index, the K. So here we have the formula K is equals to constant pressure over constant volume. So let's substitute down the given values. 0.124 BTU per pounds degree Fahrenheit over 0.093 BTU British thermal unit per pounds degree Fahrenheit. So the K would be 1.333. Next slide. So we have now solved the K. So we can now solve the final temperature. So we have here the equation. Final temperature over initial temperature is equals to initial volume over final temperature and the exponent K minus 1. So transpose final temperature is equals to initial temperature parenthesis initial volume over final volume and the K exponent K minus 1. So we're going to substitute the given values 394.06 degree Fahrenheit times 0.6 cubic feet over 3.6 cubic feet and the exponent K minus 1 1.333 minus 1. So the final temperature in run. So we can cancel the cubic feet. So the final temperature in degree Fahrenheit is 217. So but we have to convert that in Fahrenheit. 217 degree Fahrenheit minus 459.67 Fahrenheit. So the answer would be the final temperature would be negative 243 degrees Fahrenheit. So solving for the final pressure in relation of pressure and volume at isentropic process. So here is the equation. Initial pressure times initial volume, exponent K is equals to final pressure times final volume, the exponent K. So transpose final pressure is equals to initial pressure parenthesis initial volume over final volume and parenthesis the exponent K. So let's now substitute the given values. 95.3 psig pounds per square inch gauge. Convert it to pounds per square inch absolute. We just add 14.7 parenthesis or times 0.6 cubic feet over 3.6 cubic feet and the exponent K 1.333. So we can cancel now the units, cancellation of units, cancel the cubic feet. So the pressure, final pressure is equals to 10.09 pounds per square inch absolute. And now we can solve for change of enthalpy. So change of enthalpy is equals to mass times constant pressure parenthesis final temperature minus initial temperature. So substitute now the given values. Change of enthalpy is equals to 1 pound mass times 0.124 British thermal unit per pound mass degree Rankine, and final temperature 217 degree Rankine minus 394.06 degree Rankine. So the cancellation of units, cancel the pound mass, cancel the degree Rankine. So we have now the answer in BTU, British Thermal Unit, negative 21.96 British Thermal Unit. So solving for the non-flow work, so work non-flow is equals to final pressure times final volume is equals to initial pressure times initial volume over 1 minus K. So substitute the given values. So 10.10 pounds per square inch absolute times 3.6 cubic feet minus 110 pounds per square inch absolute times 0.6 cubic feet times in every square feet there is 144 square inch, and so over 1.1 is minus 1.333. So here the cancellation of units, you can cancel the psi, cubic feet, inch, and feet. So we have here the unit conversion 12,817.30 feet per pound force. So we can convert it to BTU. In every one BTU or British thermal unit, there is 778 feet pound force. So the answer in non-flow work is equals to 16.48 British thermal unit. So that's all for problem number 8. Thanks for listening.